Yeah, so the Python's I like this quote a lot because it's from Dan Callahan, and he says that Python is the second best language for everything, and I genuinely agree with that because you can make the argument that Python it's not the best language for a lot of practical reasons, but at the same time you could pretty much do anything you want with it, which is why I think it's one of the best languages to get started with. The a very close second to me would be JavaScript, and we will be doing that very soon. But JavaScript, I would say for the most part, it's really good. It's really good for working in the browser, and it's also a very good general purpose language. But for data science, for any just general business functions that you want to do, I think Python is the right language for that. So what we'll be covering today is Hello World, basic variables, basic math, loops, if statements, and functions. So what we'll be using to actually run the Python code is we're just going to go in the browser. You don't have to install anything for today. And we're going to go on to Collab. We're going to go to collab.research.google.com. And when you go to that website, what you'll be able to do is you're going to actually be able to see, like, there's going to be an introductory window. On the bottom right hand side, you're going to click New Notebook. And from there, you're going to get a screen that sort of looks like this. And in these boxes right over here, you're going to actually be able to type the code that I'm going to be showing you guys on the screen. And you're going to press this little play button on the left hand side to actually run the code. And all the code is going to be running in the cloud on Google server for you guys to actually use, and it makes it really easy to share code and run code without actually having to install anything or making sure that your friend or collaborator has the right dependencies. It just makes the whole sharing and running of code a lot easier. So this is just a little blown up view of how it looks like. And a lot of this works like a normal Google Doc. So you have your Google account right up here. You could share it like any Google Doc that you may have worked with before, except now we're running a Python notebook, which is nice, a Jupyter notebook. All right, so the first line of code that we're going to be running is just hello world. So if you actually ever done any any programming before, hello world is usually the first thing that you do. It's a very straightforward introductory thing to do because it's literally just printing onto the screen. It's one of the fundamental things of any programming language that you'd want to do. All right, so this is the Google Colab that I was telling you guys about. And just to run your first line of code, we're going to type in here, print, and in commas over here, we're going to put in some text. So we're going to just write hello world, right? I'm going to press this little play button over here. And if you look over here, we see that it's connecting and initializing a virtual machine for you to actually start running Python code on Google servers. So this nice, none of this runs locally. You can configure it to run locally if you'd want, and you need a little bit more juice. But for the most part, these are actually they're very generous with how much they give you in terms of resources and compute time. All right, so that's the first line of code that we're going to be writing. It's just hello world, and essentially this is just a proof of concept of how to print onto the screen. I think it's relatively straightforward. But if you guys have any questions whatsoever, I'm going to be going through this very quickly. It might pick up over time. If you're familiar with programming, you probably seen a lot of these concepts before. But if you have any questions whatsoever and it feels like it's going really quickly, it's because it is. We usually spend when I was a TA, we would go through all this material in about a semester. This is really to expose you guys and to make your mind start working, saying, okay, like, what if I put this with this? This is like, I'm showing you all the puzzle pieces and I'm not putting them together. I'm sort of just exposing you guys like, okay, this is how all the pieces could fit together. And the rest is up to you. So let's go back into the presentation. Okay. So just a quick fundamentals of types and variables. So in the same way that we use algebra in math, a lot of what happens in programming happens on the variables. So in this example over here, I'm taking the number 20 and I'm assigning it to the variable number with this little equal sign operator over here. So now this number lives inside this variable, and I'm able to do things to this variable. And another thing that you guys should know is that there's different types of variables. So there's strings, which is text, there's numbers, and depending on what the variable is, you're gonna be able to do different things to it. So obviously, like multiplying letters together doesn't make much sense, but at the same time, making sentences out of numbers, well, you can put a number in a sentence because you could easily transform it into text. So a lot of this is pretty straightforward and pretty logical. Like obviously you can't multiply letters together, but you learning how to use this stuff is I would say a lot of just practice, and you'll eventually get a very you'll get an understanding of like when things are like clearly wrong or when things like make sense to do. Um, a lot of this stuff is a lot more straightforward in Python because you don't have to worry and explicitly say, okay, this is a integer number. Python is very dynamic, and it allows you to just give information to a variable, and Python figures out the rest for you. Okay, so we're just gonna go over to the other tab really quick. I'll just show you guys what I mean with all this. So let me just go here. And what we're going to do is we're going to add another code block. And you might have noticed you could also add in text over here, which is really nice if you're making some sort of lab report or whatever. You could actually mix code and markup together, which is it's really cool feature. I don't know of any other programming language that does this as of right now, but I'm sure it'll come out really soon. But this is really nice if you're doing data science because you're going to have like your code running some sort of output, and you could like explain what you did. From there, we're going to go, I'm just going to write out the examples. So one quirk about notebooks is that if you have a return value, so like I'm just putting this string over here and you run it, it'll actually print out the string for you. So you don't necessarily have to explicitly go print over here to make something print onto the screen. So this is an example of a string, and one important thing that I find makes everyone's lives a little bit easier is this concept of f strings. So it's the f is for function strings, where what we could actually do is let's take a let's call it name, a variable. We'll call it name, and I'm gonna put the string Alex into this variable called name. Now in the f string, what I could do is my name is, and with curly braces, I could actually put the variable inside the string over here. So instead of having to do it the old-fashioned way of manipulating the string, adding strings together, and putting the word name inside of the sentence, I could just put the function straight in there, and I don't have to worry about making it look ugly, because the alternative before was doing something like this and adding name here and adding another, let's say some random text over here. This gets a little bit dirty, and it's not necessarily as clear. In other languages, it could be even more cryptic. Python makes it nice and simple. All you got to do is put an F in front here and little curly braces, and we could put the variable straight in there. So just to show you guys what I mean by this. So I'm assigning just to clean it up a little bit, I'm assigning Alex to name, and then name is getting transported into this string over here and printed onto the screen. If you guys want me to go any faster or slower, please let me know. From there, let's say I decide that I want to change the variable. So I could just manipulate it straight over here. Or what you could do is you could actually overwrite it. So let's go Timmy, right? So in this order of operation over here, Alex is being assigned to name, Timmy is being assigned to name. So what's happening is that Alex is being overwritten by this string Timmy, and then this latest version of name gets written over here. Sound good? All right, cool.
Yeah, go ahead.
All right, I'll keep moving
Yeah.
on. All right, so there's even more complicated data types that you could get into. Obviously, like the with most things, like programming, it could get very complicated. But I'm not going to be going into the super complicated stuff. I just want to show you guys this concept of listing variables together. So we're going to go 1, 2, 3, 4, 5. So what did I just do here? So I just declared a list, right? Actually, I can't call it just list. I'm going to call it here end list, right? In the square brackets, I could define a list by just separating what I want to put in the list by commas. So right now I put a 1 up till 5 inside of this list, and I can manipulate this entire list. So this could be a list of numbers, it could be a list of letters, it could be a list of just about anything. And there's more complicated, as I said, there's more complicated types of lists and other data structures they could go into. But what's really nice is you could loop over these, and I'll be going to be showing you what you might be and what you might end up using with a list. But just as a proof of concept, you can manipulate a list and use a list just like how you did before. It just goes straight into here, and a list could be made up of just about anything. So let's say I want to put name in this list. Well, now Timmy is the third item in this list. Relatively straightforward. They don't all have to be of the same type. They could be mixed up together. Most languages, that's not the case. You have to actually explicitly only use a single type in the list. All right, so moving on from there, we're gonna be doing a little bit of basic math. So like with normal math, like you could literally just use normal operators that you would in a calculator. So plus, minus, division, multiplication, all that is totally acceptable. And I'll just show you guys really quickly how that works. I'm just gonna go ahead and comment this out. Whenever you put a pound sign in front of a line, what's gonna happen is that Python's just gonna ignore it and it's gonna treat it like a comment. So all this stuff doesn't get interpreted by the interpreter. All right, so just to print out a simple example, let's do 5 plus 4. What's going to happen here is it's going to go over all this, not necessarily do anything with it, go to the print, and then do 5 plus 4. We get 9. I'm going to do a simple subtraction. All that happens. If I want to assign this to something, let's do output equals 5 minus 4. I could take output, put it over here, and it gets printed out. Now, the last thing I just want to show you guys, because I think this is relatively simple, is I'm going to show you guys the modulus operator. Now, modulus is a little bit confusing because what this essentially is the remainder operator. So if I were to do 5 modulus 4, what we're going to get out is 1. Because if you were to divide 5 divided by 4, what you would have as a remainder would be 1. If I were to do it for 6, it would be 2. Is this do you guys understand what I'm doing with this? If anyone's confused, please let me know. Maybe I could explain a little bit better. But what I'm going to be using this for is it's a simple trick to see if something's even or odd, and I'm going to be using this later on. So anything divisible, anything that's even results in a 0, and anything that's odd gives me a 1. And in a lot of programming languages, 0 and 1 is false and true in that order. So if you get a 1, that actually in Python and other languages will interpret that as a true value. All right, so to go a little bit further down, we're gonna be looping over a list. So I'm gonna go ahead over here, and I copy the code that I have from my presentation over here, and I'm gonna make this nice long list over here that has verbally written out 1 through 10. And what I'm gonna do is I'm gonna do an action for every item in this list. So sort of how you would say it in English, it's a little bit different, but for item in my list, right? What's going to happen is that for each item in the list, I'm going to do something, right? So I'm going to do something 10 times because there's 10 items in the list. And I can access each item in the list and manipulate each item in the list by accessing item. So what I could do is like I could print out item, let's say. So see, for each item here, so I'm going to start with 1. From 1, I get 1 gets put into item, and then I could do something with item. So I could do something with this 1. And then once all this code that's in here, it could be multiple lines of code, all just separated by a little tab. Let's just say done. Once all this code is done, it's going to go and it's going to go over to the next item in the list. And it's just going to keep doing that until it reaches to the end of the list, and then it's done. And it moves on into the next line of code over there. So this is really useful. So let's say you wanted to manipulate or see everything in a Excel column, or you wanted to do, you want to change or multiply each item in a column, or you want to actually just add everything up together. So if you were to go and take, let me change this up to 3, right? End list over here. So we're going to go, and we're going to go for item in end list. Let's calculate the sum, right? So we're going to go over here. I'm going to make a variable called sum, make it equal to 0. And then what I'm just going to do is I'm just going to do sum plus equals item, right? So then at the end, oh, what's going on here? Oh, can't do that. Well, I'll just do the simple way. So what's going on over here? Oh, wait, no. Sorry, guys. Little silly mistake. There was still Timmy inside the list over here. So that wouldn't work. So if I were to, what this error was over here is that I got to the third item over here that was Timmy, because I forgot to actually run this block of code. It came up to a word, and I was trying to add a word with a number, and Python was like, this doesn't work. Fix it, basically. So from over here, I should be able to run this now, and it doesn't do anything. Because now what I could do is I could print out the sum, and we get 15. So all the items from 1 through 5 added together, we get the sum of all of it. All good? All right. And again, guys, if anyone's confused, please let me know. Okay, so now this is another, I would think, a relatively straightforward concept. It's if, else, and else if. So if this is true, so let's just say this is true, the Python code will do this. It will run this indented block of code. It could be multiple blocks, right? But if this is false, what Python will do is it'll go over to the next line here, and it'll check for the else if or the else block. If the else if block is true, it'll do that. But if both of these come out as false, then it'll just do else. It'll do if all of these fail, it'll just do else. And you could have multiple of these. You could have multiple else ifs, and you could have them all chained and embedded within each other, and all this will work, right? All these failed, so it's going to do what's else. This one's the only one that's true, so it's going to do that. But it will do them in the order that it finds them. So if one of the above elifs is true, it's going to ignore everything that's below it. It won't run them concurrently. It's a simple check. If true, do this. If false do that in the simplest of terms. But there's all this other syntax that you could use to add more complicated logic to it. How we actually get these true and false operations is with comparison operators. So comparison operators are just like in math. You're greater than or equal to, less than or equal to. This is where it gets a little bit different from normal algebra. Is the equal operator. So normally we would just do equals. Well, this is an actual operation to see like, is this equal to this? So like, is 1 equal to 2? Well, that would become false. This other one over here is not equal to. So if something is not equal to it, then it's going to return true. So if is 1 not equal to 1, false. They are the same. So it's going to return a false. So these are just opposites to each other. So just to show you guys a quick example, I'm just going to do a print is 2 not equal to 2? False. Is 2 equal to 2? True. So then what you could do is you could take something like this. So if 2 is equal to 2, it's going to do this. If it's not equal to this, it's not going to run it at all. All right. If anyone has any questions, please just go throw them in the chat. All right. So now we're going to run through just a quick example of starting. I'm going to start putting all the pieces together. So what I'm going to do is I'm going to go and I'm going to take a list. I'm going to look at each item in the list, and I'm going to want my program to print it out only if it's even. So I'm going to go ahead. I'm just going to copy paste it from my presentation over here. Let's put it over here. And I'm going to break it down just line by line. So I declare a list, right? 1 through 10. And then I write myself a little comment here. So print out all the even numbers. So for each number in this list, if the modulus of the number equals 0. So remember, like I said before, if the remainder of this is 0, that means it's even, right? If it's even, print it out. So we're going to run this code, and we're going to get all the even numbers out of this list. So this is sort of like just a quick and dirty example of how we could take a few of these concepts together, these puzzle pieces of logic, to sort of make Python do what we want it to do. So something that we could do with lists, to get a little bit deeper into how lists work, is we could actually use a remove function. So functions are these things that they're rather explicitly written, or they belong to a class or a data structure that you find in Python. So something like lists, inside lists are a bunch of functions that are defined that you could actually go in and you could actually go look at the source code for all of it and see how it all works together. But under the hood, there's this function called remove, and we can access that function with the little dot operator over here. What remove does is it just takes an item out of the list, does what it says. So I'm gonna run this list again, so that way I don't have to worry about something missing from the list. So we're gonna go through each item in this list over here. We're gonna access that number. If it's equal to 0, if it's an even number, we're gonna take it out, and then we're gonna print it over here. So what we're gonna get is we're gonna get all the odd numbers now. That makes sense because we removed it from the list if it was even. All right, so a lot of the times, like this remove function, we're going to be making our own functions. So there's this principle in programming, and I guess a lot of disciplines, is don't repeat yourself, right? So if I was gonna do the same thing over and over and over again, I don't want to have to explicitly write all that code over again. I don't want to have to redefine the removal of even numbers in a function many times over. I'll put it in a function so that I could call that function whenever I want and make my code a lot more condensed. So this is just to bring it back a little bit more simpler. This is how you define a function, right? The little def, you give the function a name, the little curly braces and the colon over here, and then every time you run my function, this is how you call a function over here. It's gonna run all the code inside of it. So this is the definition of the function, and this is me using the function. All good? I'm gonna assume that everyone's with me. So we just could go ahead and no worry about it. So yeah, so we're calling a hello from a function over here. Relatively straightforward, but functions could get a little bit complicated. And one of the ways you could actually complicate them a little bit and add more logic to it is you could actually give functions parameters over here. So like we did with the remove function up here, where we gave it the number that we wanted to take out, right? When you define your own functions, you have to go and you have to actually give a name or a variable and what you're going to do with that variable. You could give parameters to the functions. So in my function over here that I'm defining, I'm going to print the first name and a last name, right? This is my name. And I'm going to pass it a string, Alessandro. And what it's going to do is I'm going to go over line 1. I'm going to define the function with line 1 and line 2. It's going to skip line 3. And then on line 4, none of this code actually ran yet. So on line 4, this is actually when we jump to line 2, we start running this code, right? So over here, it actually goes and it just prints Alessandro Gicolello. We could change this. We could pass it any number that we want or any variable, any string, and it'll do it. You could actually even pass it numbers, because wait, no, can we pass it numbers? No, if it was an F string, we could have passed it a number. But yeah, let's just change this to an F string, right? Put F over here. I'm gonna pass it first name. Close it up. Now it works. Now you don't have to. It actually just casts it over all together, and it sort of just works. Add the what you do with this parameter over here, you could arbitrarily name them whatever you like, but the basic principle is that you could give a function some code or some variables, and it'll do whatever it needs to with that function, right? Another thing you could do with functions is you could actually have them return data to you, right? So let's go over here, and let's say instead of just printing this whole name out, let's say we wanted the function to actually just return it for us. So what would that mean? What does that mean when we return some data? What's gonna happen here is I'm gonna give it a name. I'm just gonna give it Alex, right? And right now Python is printing it because it's a Jupyter notebook. But if I were to go ahead and just do something like this, like variable equals my function, it's not actually doing anything, right? It's, nothing's being printed onto the screen. It's sort of all happening in the back. And what we're doing is we're actually we're passing this output over here into this variable, and we could print this variable out right over here. Hopefully that makes sense to you guys. So whatever I pass into it, it's going to manipulate it, and it's going to print it out. And now this is the last little section where we're going to use, we're going to actually just put all the things I showed you guys all together, and we're going to make a list of numbers, and we're going to print out everything that's even in that list, but we're going to use functions to do it. So over here, so just so I don't make any silly typing errors, I'm just going to copy it from my PowerPoint. And over here, this is I'm just going to break it down line by line for you guys. I create an array over here with some random numbers inside. I define a function in line 3. And as far as the interpreter is concerned, what's inside that function doesn't matter yet, right? I'm just going to hide it from you guys. Then we're going to go to line 10. We're going to take this list. I'm going to pass it to the function. Now Python's going to look inside the function and be like, okay, I have this variable I called find even. I'm going to do something with it. So now numbers goes into list of numbers. And we're going to go through this block of code over here. So for number in list of numbers, we're going to check to see if it's even. If it's even, we're going to print it out. Relatively straightforward. And all the even numbers have now been printed out in order that they show up in the list. Any questions? If anyone would like me to go over any of the specific sections because they don't understand a specific piece, please let me know. You could even DM me. It'd be fine. Well, all right.
Sorry, I have a question. So when you use the F, that made the numbers go in the same order as the list?
Okay, so this F over here?
Yeah.
Okay, so what this F does is it tells Python that this is a function string. So function strings are basically they're normal strings, but they allow you to put functions within the curly braces here, and it puts that variable. It sort of injects whatever's inside that variable inside the string for you. So what I easily could have done is actually this is sort of redundant because I'm not actually adding any text into here. So now if I run it this way with this random code, it's going to inject this number between these ASDFs, this random text in the middle. But I don't necessarily have to do this. I could just print out like this. And this is just as valid as it was before.
Okay, thank you.
Yeah, so function strings is just something I like to use because it makes adding all this it makes adding variables into an output that makes sense. So you're not just getting numbers. You understand okay, this is the number coming from this part of my code, and it just makes it easy to inject those numbers into it. So especially if you're working with multiple numbers, or you're printing out some sort of table, it just makes your life a little bit easier. All right, if you guys if you guys have any questions, please let me know. This is actually the end of the first PowerPoint that I have. I actually have a second one where I go a little bit deeper. So if you guys want to know a little bit more, I actually could dip into that second PowerPoint. Otherwise, please let me know. Normally, this is where we would break out into groups. But given that today is sort of just a revisitation of what we